All right, so the equation for a parallelogram, all right, is one of the equations. What's another equation? Yeah.
For a triangle?
Yeah, the equation for a triangle. And what else? Yes?
The area of a trapezoid.
The area of a trapezoid.
That's a long one.
Equation for a trapezoid. Yes.
Quadrilateral.
Quadrilaterals, which we'll get to in just a minute. We're going to get there. Okay, this is good. That's very good. Okay,
Equation memorized.
first of all, yes. Equations for these three things, but we're dealing primarily with this concept called area. Okay, area is not particularly easy to conceptualize, which means to think about. Okay, area, if I had a figure, okay, and this is the figure, okay, the area for this figure is all of the space inside it. Where does this become important in your own lives?
House.
Yeah, in your own homes. All right, have your parents ever had to get anything where they had to think about area, do you think?
Yeah, wood floors.
Oh, wood floors. Absolutely. You have to know the dimensions of your floor. Where else? If we're thinking wood floors, we can also think
Carpet. Boxes.
carpet, boxes.
That's volume though.
Furniture.
Boxes deal with volume, but that's very interesting. When you buy a house, how do you classify the size of a home? By its square footage. Okay? And oftentimes when we buy boxes based on the square footage of our home. Okay? Yeah.
Furniture.
Furniture.
My parents should
What's
love
a box?
furniture.
A box?
Like
A box is an
box?
object that's got flaps on top, made of
No, like
cardboard,
the house
usually
is like a house.
looks like a cube.
And you put stuff inside.
More oftentimes rectangular prism, but yeah.
No, like what's a, like he was talking about boxes. Why would you need to know?
Because when you pack up a house, oftentimes the size of your home determines how many boxes you buy, because they can average the amount of stuff you have. Okay, so when I moved to Indiana, I lived in a 1,000 square foot house. So I knew how many boxes I need, because you go to them and they say, what's the size of your house? And you say 1,000 square feet, or roughly 1090 square feet. And they'll be like, oh, you need this many small boxes, this many medium boxes, this many large boxes. Okay, because the average person, or the average family, or the average couple, etc., has about a standard amount of stuff. Okay, especially here in America. All right? So you'd be surprised. So area is the space inside something. Okay? Now, we're going to start with a parallelogram, but then we're going to actually be able to use this to find the other equations, believe it or not. I'm going to tell you right now, these first two are the most important, because you can find the area of almost anything if you know the equation, especially the equation for a triangle. All right? The only thing you cannot find is anything that's got round or curves. But triangles, if you know the area of a triangle formula, you can probably find the area of anything, and I'll show you how that works. All right, let's start with a parallelogram. So I'm going to draw a parallelogram. You should do the same. Okay, there's my parallelogram. I know it's a parallelogram because it's got two sets of parallel sides. Okay, this is a quadrilateral. Why is it not a rectangle? Yes? It's slanted. Yes, it does not have four right angles. Why is it not a square? Yeah.
It doesn't have four congruent sides and four right angles.
Right. Why is it not a rhombus? Yes.
Because it's like,
It's slanted.
it's like,
Yes, it is this way. Yes.
there's not different. Like,
Why is it not a rhombus?
they're not.
Pick on me.
Oh, okay.
Reagan.
There's not two set pairs of
Yeah,
Well, there is, but in the rhombus there's not.
Think about the sides of sides.
Oh
There isn't
my
a rhombus.
gosh.
That's very good though. A rhombus looks like.
a rhombus looks like that thing turned on its side.
Oh, I was smaller. Wait.
Mary.
No, it doesn't have four congruent sides.
Does not have four congruent sides. Right. All right. So.
Like a square more than a triangle.
All right. So we have a parallelogram. There are two aspects to a parallelogram that are going to become important, and we use the same convention, which means it's the way we look at a diagram in all three of these situations. Okay? The first being that when we have to look at the height of a figure. The height of the figure is how tall it is. Okay? It can be measured in multiple locations, so I might decide that this is the height, right here. Or I might decide that this is the height, right here, even though it's outside the parallelogram. Okay? What it is if you were to take a tape measure from the top parallel line to the bottom parallel line, that's the height. Notice that I kind of extended this parallel line out, not really, that's why it's a dotted line in a different color. I kind of extended out here, but notice that the height is always measured perpendicular to the surfaces. Okay, that's important. Perpendicular to the surfaces. Okay, so the very topmost part measured down perpendicular to the base. Okay, so the height is here, which leads me to the next part. This is a base. The base is what the figure rests on. It's kind of like a lamp base. It's the bottom. Okay, a base, a baseball base, something we stand on. It's the bottom. Okay, a base is at the bottom, base bottom. Okay, so this is a base. All right? And yes, if I flip this figure upside down, the top would be a base, which we'll get more into that when we get to trapezoids. Yeah.
So like in an orchestra, like the giant guitar bass is always at the bottom.
Always at the
heavy.
Always at the bottom, yes, well, at least in sound, of frequencies as well. That's why they call it the
It's not a
bass.
giant guitar.
Yes, it
Okay.
is.
It looks like a giant guitar. String structure is very similar. Needless to say, this is a parallelogram. Now, if you want to find the area of any parallelogram, which includes rectangles, squares, and rhombuses, okay, because remember the hierarchy, everything, rectangles, rhombuses, squares, all fall under parallelogram. So this equation works for all of them. Parallelogram literally means parallelogram, rectangle, square, rhombus. Does not include quadrilaterals, per se. Because I can have an off quadrilateral and this equation will not work. Yeah.
So you would use this equation and the equation for a trapezoid and have the same numbers and you get the same answer?
Not necessarily.
But then you just said that you could use that.
I can use this information to modify for this. You'll see. You'll see. The area, a space inside the parallelogram, is just the base measurement times the height. So any parallelogram, if I know the base and the height, I can find enough information to find the area of this parallelogram. Okay? So the equation is area equals base times height. It's very simple. Very simple. Okay. Now, let's start with a parallelogram again. Okay? Let's start with parallelogram again. And let's say that we know the area equals the base times the height. We know that. So the area is all of this space in here. Okay, great. Is there any way to divide this into triangles? Yeah.
Like diagonally.
Okay, I can do one diagonally, sure.
No,
Like this way?
Yeah.
Okay, let me do that way then.
That just looks like two triangles.
How would I find then the area of this triangle? I would tell you that these two things are the exact same size. So how would I find the area of one of these triangles If I knew the area of the parallelogram, yeah.
Half.
I just take half of it. Perfect. Yeah, nice.
Isn't the
That's-
equation for a triangle half?
Oh, yeah, whoa, don't, whoa, whoa. Okay, we're almost there. So, let's just make sure that we're not looking at this funny. New parallelogram.
Oh my gosh.
That looks like a square.
Hey, yo, don't be bragging on my parallelogram.
The square is. Wait, is this for the equation of a triangle?
Yes.
Okay.
And I'm going to draw it the other way now.
Wait, that's for a triangle right there?
And look, it's still 2 equal halves.
How many should we
So if
draw?
I want to know the area of the triangles, I just take half. So the area of, and sometimes when you're doing an area formula, if you're trying to differentiate what you're talking about, you can put a little symbol next to it. So that's the area of a triangle
Whoa.
equals 1/2 the area of our quadrilateral, or our parallelogram here. Ooh, not quadrilateral, parallelogram.
Yeah.
Base times height. So the area of a triangle is literally half the base times the height, which is the area of the parallelogram. So that was easy enough. The area of a triangle is just half that of any parallelogram. Mary?
What if you just had like a plane triangle?
If I plane triangle,
Just a normal triangle without having a parallelogram.
good question. So let's say I had a triangle that looked like this.
Oh my gosh.
Any triangle can be made into a parallelogram if you copy the triangle and flip it. So if I were to copy this triangle and flip it, then it's a parallelogram, and this is 1/2 of it.
It's a kite.
So any triangle, even if I'm starting with a triangle, is half of some parallelogram. Okay? If I were to take two identical triangles anywhere, and put them together, they will always form a parallelogram. That's why this works. That is a great question. It's a great question. Do you understand my answer, though? If I take two triangles and if I take a triangle and I clone it, two of the same, and I put them together, they will always form a parallelogram. It's awesome. It's awesome. I should get a shirt. Parallelogram on the front, two triangles on the back. Mm-hmm.
Or you could say I heart parallelogram.
That's really.
Maybe we should get a
I
shirt
do
that-
heart parallelograms.
Oh.
Yes.
Or you should get a shirt that
For
says.
the triangle, like, couldn't you just take the one side because it's the same? Like, I mean, like, so like, well, okay. So if you look at it,
Yes, I'm looking.
the two short sides, like,
There are two short
that are
sides.
the hypot.
Yes.
So are those the same as the other one? So you wouldn't really need to draw it. You just take those sides as your what?
You would not. Okay. I think I know where you're going with this. That's good. You would not need to create a parallelogram to solve it. Okay. You would just need to find the base and the height to solve any triangle, and then take half of the product of the base times the height.
There doesn't have to be a
There doesn't have to be a parallelogram, but what I was trying to get at with Mary is, if you have just any triangle, the reason this equation works is when you clone it, you make a pair, a copy that's exactly the same. These two are exactly the same. These two are exactly the same. And you put them along so that they're next to each other, they will always form a parallelogram, or they can always form a parallelogram. Chloe.
If you had just a triangle and you had the base and the height of that triangle, wouldn't you have to double the height? Or
Nope.
a single triangle? 'Cause it would
If I had a
be-
single triangle like this, this would be my base, this would be my height.
No, not that one, the other one.
Okay, so this one,
Oh, never mind.
this would be my height, this would be my base. I'd multiply the two things together and I would divide by 2.
I thought the base was on the bottom.
It's not always on the bottom, you have to find a flat side.
So the
Okay,
hypotenuse could
let
be
me
this.
draw 3 different triangle images so you can see how the base and height differ in each one. Okay? So I have this one, and I want to make sure that it's showing up in my video. Oh, gotta scoot it over just a little bit here.
Can I hear everything
Uh-huh.
you said?
Yeah, absolutely.
Great.
All right, so there's a triangle. Here's a triangle. There's a triangle. Okay? If I were to draw the base and height for each of these triangles, I recommend you do the same in your notes. This is what it would look like. This would be my height of this one, because it's from the topmost part to the bottommost part. And this is the base. So I know base and height here. This one's easy because it's a right triangle. So the height is here, and the base is here. And so you're literally just multiplying the two sides of that triangle.
That's kind of like mine.
So this one's kind of easy. This one, not easy. You actually have to think about this being the height, and this small little section over here being the base. Okay? So what I have going on is I always have to draw from the top of the triangle to the bottom and make sure that they're perpendicular. Perpendicular, perpendicular, perpendicular. That's how I find my height. My base can always be my bottom side. In this particular triangle, Grace, you asked a great question. Doesn't your base have to be the bottom? In this one, there is no bottom. So I get to pick. See how unless you count that point, you can't measure a point. So I have to pick a side that's bottom. So really what's happening is this one, it's like an upside down this one.
Wait, can't you just pick the other side?
As the height?
No, the red side right there. Yeah.
Oh, if I were to have drawn the red side, I could have. Yeah, but in theory,
Oh, okay.
that was not part of the original triangle.
That makes more sense.
Okay, I'm glad it does. Good. Colby.
Also, couldn't the height be the point to the hypotenuse?
Could it be the point to the hypotenuse? It could have been,
Not
yes.
the weird thingy off the side.
Yes, it could have been the point to the hypotenuse, and the hypotenuse could have been the base. Yep. Some people find this easier when they get into harder problems. Some people find this easier. Depends on what your book gives you. Sometimes your book will give you this, or sometimes they'll give you this. Depends. Yeah.
Can you figure out the height of a triangle if they don't give it to you? Like, how would you?
There are ways to do that. We're not there yet.
Is that like the Colbert theorem?
The Colbert.
C squared equal, or no.
Pythagorean theorem?
No, the Colbert theorem. C
we're-
squared minus A squared equals
Jade.
B squared.
Did you mean to make the last one look like a paper airplane?
Nope, but it's awesome. All right, here's what we're going to do. We need to get to the equation of a trapezoid. Okay? Equation of a trapezoid is a little bit more complicated. So what we're going to do today, we're just going to draw what a trapezoid looks like and break down the parts. Okay? So I'm going to go ahead and erase this. Hopefully you have it written down.
Oh, darn, I don't.
Oh, shucks.
I didn't write down anything.
Congratulations, Colby.
You've just picked up someone's face.
It would be a shame if I wrote anything.
They're doing the test.
Okay, here we go.
All of it.
There are several different designs of trapezoids. This is one.
Oh my gosh.
That's one. That's one. Okay, this is a right trapezoid. This is an isosceles trapezoid. Okay, I'm going to draw a single dash there and a single dash there. And this is a
I thought that was only for triangles.
scalene trapezoid. Okay. This one they're all just a little bit different, but the equation works the same for all of them. First of all, every trapezoid has one set of parallel lines. That's what's unique about trapezoids. That's part of their very definition. They have to have only one set of parallel lines. Those parallel lines are, on this one, here and here, here and here, and on this last one, here and here. Okay, so those are the parallel lines. The parallel lines on a trapezoid are where your bases are. Okay? Your bases will be your parallel sides, not your uneven sides. Hang on one second. So here's what we do. We call the top one base 1. We call the bottom one base 2. So base 1. And sometimes, in order to solve problems with trapezoids, I find it much easier to redraw the figure if it's not already on one of the bases. So base 1 and base 2. So like if, for instance, your trapezoid was standing up on end, like this, technically, this is base 1, or these are your bases. But they're not. See, the base is usually on the bottom. So in my head, this is all messed up. Okay? So here's a base, and here's a base. Okay? Well, they're kind of going up. That doesn't make a lot of sense. So I would turn it on its side to solve it. Yeah?
Can base 1 be the bottom?
Base 1 can be the bottom. There's no reason that. It's just, I just usually number down. So that's why 1 and 2 is the way it is. It could be, if you're a bottom-up kind of person, 1, 2. That's fine. So I'm a top-down. You might be a bottom-up. That's fine. Okay? We just might be opposites, which is fine. Yes? Or you just don't care either way. That's a good question. Yeah?
When you're writing parallelograms, dude.
Ah!
No,
See, those are her initials.
No, I'm.
Continue.
I'm parallel lines.
What about parallel lines?
Does the arrow have to go that way?
No, it doesn't. I just put the little caret there to show that they're parallel.
But can the
Yes,
Caret go the other
it
way.
can.
Yes. You could also have double carets. You could also draw little cheese symbols. It's up to you.
Seriously? Can I draw cheese?
No,
Dang it!
you'll take that too far. Too much cheese on your paper. Okay.
No, it goes in my mouth.
cheesy?
It's, yeah, that's good. Okay.
Next one.
All right, we only have a few more minutes. The next thing you have to find on any trapezoid is the height. Same as a triangle. Connor, where do you think the height is here? Remember, the height is always measured from the top to the bottom.
Right side.
The right.
Like, where on the right side? The one with the right angle. Connor, why didn't you get up and show it?
Along the right angles. That's fine.
The one with the right angles. Yeah. And this one, this side is the height. Okay, that's true. Can we do that here, though?
No.
We can't because it's slanted. So we have to do the same thing we did with our triangles. And we draw in the height. And the same thing over here. And it doesn't matter where we do it on these, so long as we're going from the top.
To the bottom.
Wait, for the one that you could, for the first one that you did, couldn't you do the
Yes.
dotted dash line thing?
Right here?
There.
I could have. And yes, it would have worked. I don't usually, because they usually, but yes, I could have.
Yeah.
There's a lot of places I could measure height here, or here, or here. Very good. These are good questions.
Or on the outside.
Guys are,
Or
guys
on
are
the
little.
outside with the little do-do-do and the do-do-do.
Now we put the equation together. Do. And it looks like this. The area of a trapezoid is 1/2 times the height. Okay, and now I'm going to have some parentheses. 1/2 times the height, and you add the bases. So we put base 1, b sub 1, plus base 2, b sub 2, close parentheses. So let's walk through this real quick. What would you do first in an area of a trapezoid problem? Yeah,
You would add the two bases.
you'd add the two bases because that's what's inside the
Parentheses.
parentheses. Okay? Then I would multiply the 1, the half, and the sum of the bases to find the area. There is another way to look at this problem. I'm going to show it to you briefly because we have just a few moments. Sometimes they're going to give you the area, and they might want you to find one of these sides. Okay? So you can use the distributive property here by multiplying this 1/2 h by both of these things. So there is another way to look at this equation, a little more complicated than this. I'm going to have you put it in your notes, and if you ever come up against a problem where they want you to find one of these things, at least you'll have it, okay? So what it looks like is this. The area is equal to 1/2 h times b1 plus 1/2 h times b2. That's the second formula for a trapezoid, and you can probably see why that's not the one that we usually stick with, because it's considerably more complicated. Okay? So there's the other one. I recommend, almost for every problem, this guy right here. Okay? But notice that the distributive property works here. If you needed to find something, you could. Any questions?
No.
Okay. You are going to use these equations tonight in your homework. We didn't get to go through too many examples of how to use them. You have used equations before. Pause. I recommend for every problem doing the following. I'm going to go ahead and erase these. And the reason I recommend this is because I know from experience that this will benefit you in every way. Let's say number one, they give me a figure like this. No. Okay? They give me a parallelogram, okay, where the height is 17 and they tell me the top is 22. Okay? First thing I do in a problem like this is I say, okay, they want me to find area. So I put in my paper or in my work section, find area. To do that, I write my equation, A equals BH. So the first thing I do is I write my formula. Second thing I do is I build what's called a toolkit. My toolkit, I did do this with you before. The toolkit is everything I need to find. So I write down everything I need to find. I need to know base, and I need to know height. So then I go to my diagram and I say, what's the base? Ooh, the base is down here. What do I know about parallelograms that would help me solve this? Mary?
The top side and the bottom side are congruent.
Oh, perfect words. The top side and the bottom side are congruent. So 22 is actually my base. So I put 22 here. It's not showing up super great, but you get the idea. My height is given for me. It's 17. It's right in here. Last but not least, I then go over here and I start plugging in what I know. 22 times 17. When you have two things next to each other in parentheses, you can multiply. Okay? And that works out to being roughly 400, but somebody?
374.
374?
Yeah.
You were 26 off.
I was. I used my estimating strategies, 20 times 20.
What the
Okay? So the area, this is the last thing you do. Area is always measured in units. Does anyone know?
Squared.
Squared.
Ow.
If we don't put that, do we get the entire problem wrong or just half?
Can we put U squared instead of units?
I'd rather you do units. Because that,
I thought it was 374 squared.
no.
I mean, oh wait, no.
Because 374 squared is like 9.
Pretty
It's like
high.
1,000 something or another.
Okay, we're done for the day. Thank you, ladies and
What's
gentlemen.
our homework?
Hang on.
Emma!
Emma!